Hello, so this is the Module 2 review. This video is going to be a little bit longer because I'm trying to show you some similar problems for each of the lessons. So just hang in there. You might also want to use it like a learning check. Pause and try each problem on your own and then check the work so that you know you're ready for that test. Okay, Destiny's trying to find a route for the kids' race next week. It has to be a distance of 16 blocks. That's the path. Compare these options for their displacement. Okay, position final minus position initial would be your delta x or change in distance. It doesn't normally tell you on the test to draw pictures, but I do try to keep that up there a lot so that you remember it when you're working on these. So 8 blocks east, that's a positive 8. And then 8 blocks west, that's a negative 8. Okay, now, when we're talking about the path, we're still going 16 blocks. So we're meeting that distance requirement. So we could calculate the speed using that 16. But my displacement is going to be 0 blocks. Okay, so my velocity of the overall trip is going to be 0 because we started and ended at the same point. So that is that displacement. 0 meters. Okay, number B, 4 blocks east and 12 blocks south. Now, so our path is what? 4 plus 12 is equal to 16 for our path. Our displacement on this time is going to be going from the start to the end. So it's going to be going southeast, or you could also say this is east of south. Oops, that's east. South of east would be the other way to describe it because we're on this line here and then we're going down to the diagonal. So always find that horizontal and then describe how you get to the diagonal. Okay. And what is this magnitude? Well, this is the side opposite the 90-degree angle. So that is our c squared, or our c side. So we can use Pythagorean theorem, a squared plus b squared equals c squared. 4 squared plus 12 squared equals c squared. Now you wouldn't just solve it like this. Why? Because the magnitude is c, not c squared. Okay, so we need to take the square root of that whole thing. Use parentheses if you're not using a program where you can see that the square root is going over the whole thing. So that would give us the magnitude. How would we get the direction? The direction would have to be gotten using our theta if they wanted a specific one there. What about C? 6 blocks north and then 10 blocks west. And so what is our displacement on this one? The start is here before the 6 and the end is after the 10. So this one is going to be going northwest. Okay, or how else do we find it? We find that vertical. Okay, so that's north. Okay, and then are we going what direction from that? We are going to the left. So that's west of north for that answer. West of north for that theta. Okay. Our path is still 10 plus 6. And our magnitude of our shortcut or of our vector is 10 squared plus a 6 squared. Okay, number D, 6 blocks west and then 10 blocks south. So this time we are going to be going in the southwest direction, or west is our direction. And we're going south of that. South of west would be our angle for that one. What would be our magnitude? The square root of 6 squared plus 10 squared. What did I notice? This magnitude and that magnitude are going to be the same, but their directions are totally different on there. So these guys might have similar magnitudes, but they have different overall vectors because remember, vectors are magnitude, units, and direction. All three have to match for the vectors to be equivalent. What about number E? That's 16 blocks east. So that's basically 8 and 8 for a total of 16 east. So my highest magnitude is 16. My lowest is 0. So when we're trying to compare the displacements, see what you can do to make the smallest number and then see what you can do to make the largest number. The largest number usually means not having any angles in there because then we don't have to do the Pythagorean theorem. And the smallest is usually trying to go back upon itself. So even if it was 10 blocks east and 6 blocks west, then you would have leftover of what? You would have 2 left over. So in that case, the range would be between 2 and 16. But we know we can put an equal number on both sides. So that's how you would compare those. Which one would you want? That's really subjective, right? So if you ever get an essay question like that, just decide, oh, this guy's nice. We all park in one spot and the kids run and come back and I can stay in one place. Or this one's nice because if I want to run along and cheer them on, we're all going in one path along with them, but that might be causing some crowd issues. But then the kids would be less likely to be confused about where to go when, because it is just a straight shot. So there's lots of different things that you can think about in that manner. Tony Hawk throws his skateboard horizontally at 5 meters per second and it lands 3 meters away. What is the height of the ramp that he's on? So he's on the top of the ramp. Okay, so he is standing over here on the top of the ramp and he throws his skateboard. Okay, and he throws it horizontally, 5 meters per second horizontally. So that's the velocity in the X. What's the velocity in the Y? 0. Because he threw it horizontally. There's no change in the vertical. You didn't throw it up, you didn't throw it down. So we're going to start off what velocity in the X is 5 meters per second and velocity in the Y is 0 meters per second. It lands 3 meters away. Okay, 3 meters away. That is the distance in the X or the change in the X, the delta X, or the range is 3 meters away. Okay, what is the height of the ramp? That is what we're trying to find, the height of the ramp. So this is a very similar problem, but in reverse to what else we were doing. This time, they want us to find the height instead of the range. So that means we just got to do the order of the problems backwards. And if you're like, nope, I have no idea what you're talking about, write down what equations you do know, because those are going to help you after you draw the picture. Okay, because why? Free fall time is equal to projectile time every single time. So you know the times are going to be equal because that's what we've been working on. So now I got to figure out what equation do I have? I have the range is equal to velocity times time. What velocity? Velocity in the X. Why? Because it's distance in the X. So for this, do I know the range? Yep, I know the range is 3. Do I know the velocity in the X? I do, it's 5. What's the only thing left? The time. So my time is 3 over 5 seconds. So in this case, they gave us the range. So we use the range formula first. When they give us the height of the cliff, we use the Y formulas first, because that's how we can eliminate the most variables and be able to solve it. One variable per equation so that you can solve it. Now that gave us the time. Okay? And so remember, our projectile time is equal to our free fall time. That is that principle that is carrying us through there, just like I said at the start of the problem. So now we have our time, but we need our height, which is our distance and our Y. Do we have a formula for distance and Y? We do. The same formula from module 1. Velocity initial in the Y, that's 0. Time, 3 over 5. Acceleration, negative g. Okay, because gravity is pulling you down. Your acceleration is due to gravity, and since it's down, it's in the negative direction. And then that time is 3 over 5. So since we have the time from the range equation, we can substitute completely in there, and then we can find our height or our distance in our Y. Remember, all the time report to 2 decimal places unless it's a really small number, and then add some more decimal places. Never hurts to have more rather than less. All right, how long does it take to get from A to B? The twin prop plane takes off from point A and heads towards position B, 500 kilometers to the west. Okay, this is the west direction, 500 kilometers, you know, and I'm going to fix that right now, 500,000 meters. But always read the problem to see if you're supposed to convert or not. Sometimes you are, sometimes you're not. It's going that way at 100 meters per second. This is the plane. Okay. But because of a super strong crosswind perpendicular to the flight, okay, so that means that that could be going up or that could be going down, whichever way you wanted to draw it. It does not specify as long as it's perpendicular to the flight. And that wind is 35 meters per second. The plane would end up at position C if no correction was taken. So this is position C down here. So my actual velocity is going to be going where? Southwest, because it's being pushed off course. Okay, it is going south of the west. Now, what question do they want us to answer first? Find the X and Y velocities. Okay, well, that one, remember, we don't have to use sine and cosine. It already tells us the X and Y velocities. We just have to know which one's which. The plane is on the X path. So that is actually going to be negative 100 meters per second. And the Y is going to be negative 35 meters per second. Now, they didn't specify which way the wind is going. So if you had positive 35, because you had it going in the upward direction, then that absolutely just has to match the picture. And you notice I just have 135 here. These are what? These are the magnitudes. So they are the absolute values, what I put here, because I know that's what we're going to need it for later is the magnitudes. But according to my picture, both of these would be negative. We went to the west, we went to the south, negative. If I had to find the time, what could I use? What thing had two? If you noticed, when I looked at it, that X direction had both the velocity and the distance. So it had two parts of the range equation. It had the velocity and the distance, so we could solve for time. Or velocity equals distance over time. I had the velocity and the distance, so I could solve for time. So again, if you're like, whoa, I didn't know why you would pick the range one, just write all the equations down. Write the range equation, write the height equation, write the other ones from module 1, and start circling what you know and see which one only has one guy left. And that's who you would start with. Okay, what is the velocity of the plane with respect to the Earth? So this one only wants to know about the velocity. So 100 meters per second west, 35 meters per second. And again, I chose down, but you could choose a different way. Okay. So our velocity resultant would be the hypotenuse. Every time you're looking at this, if it's the vector, it is going to be on the hypotenuse side. So we can use the Pythagorean theorem for this. That's our C again. 100 squared plus 35 squared, square root. That is going to give me what? The magnitude again. It's giving me the magnitude. What's my units? Meters per second. Why? Because the other two are meters per second. If one was miles per hour, I would have to convert that so that we're talking about apples to apples. And direction. We are going to be going southwest. Could we actually find an angle? Absolutely, we could find an angle here. What can we use to find an angle? I know 35 is the opposite side and 100 is the adjacent side. So TOA is who I'd find. Tangent of theta is equal to the opposite over the hypotenuse. Theta we do not know. The opposite is 35. The hypotenuse is 100. So even though these aren't the X and Y of the same thing, they are actually still the X and Y of how the plane is traveling with respect to Earth. So it doesn't matter that one is the wind and one is the plane speedometer, just like the boat speedometer and the current was able to be used in this manner. Now I want to find my theta. So I got to do an arctan, and what I do to one side, I got to do to the other. And that's how that cancels off to find that angle. So, and that angle is going south of the west direction, south of west or southwest. Sometimes it's the same, sometimes it's reversed around depending on which one is the horizontal. Okay, so resultant velocity, Pythagorean theorem again, finding the angle. Draw your picture to help you out every time. Draw your picture. How far was the plane pushed off course? So this time we want to talk about the distances. We want to find the distance here in the Y. Do we have the distance in the X? Yep. Do we have the theta? Yes. So that is one way that we could find it. We could use the tangent again this way, but with 500,000 meters to make sure you're comparing apples to apples. So if they want the answer in meters, use 500,000. They want the answer in kilometers, use the 500. So that's one way you could do it. Is there a second way? Yep, oftentimes there's multiple ways to solve the problem. What else do we know? That distance is the Y distance. Do we have Y formulas? Yep, all three formulas from Module 1 can be used for all X's or all Y's. Okay. So we know the velocity in the Y is the distance in the Y over the time. Do we have the time? Yes, because the time on the X loop is the same as the time on the Y because they all meet up in the resultant. So again, we can use that time as an equivalent to go between the places. What's my velocity in the Y? 35. The time we solved earlier from the range equation. And then we can solve for the distance. So there's two different ways that you can solve for that distance to help you out. Now, what if they wanted to know what the actual distance the plane was on? Well, we know the distance in the X, we know the distance in the Y, so we just need to find our C. dy squared plus dx squared is equal to C squared. Same methodology every time, same methodology, even if it's described differently. And there's just that little picture again to help you out. All right, new one. A motorcycle stunt person is traveling 50 or 70 miles per hour at an angle of 35. They want to know the X and Y components at miles per hour and miles per hour. So these guys are matching apples to apples. So I don't have to convert from miles per hour to meters per second, but read carefully. It's all about making sure you're answering the question they want, not the question you want. What's going to help? Drawing a picture. Okay, so we have that picture here. We know the angle is 35. We know the resultant is 70 miles per hour because that is what's happening when it goes off the ramp. It's not split into its X and Y components. X is on the adjacent side. Y is on the opposite side. Adjacent uses cosine. Opposite uses sine. So what is my equation? Vx is equal to V cosine theta, Vy, V sine theta, 70 times cosine 35 for the X direction, 70 times sine of 35 for the Y. Do make sure you're in degrees. That's the #1 problem for a problem that you get similar to this is you're accidentally in radians. Okay. If you're using Desmos graphing defaults to radians. So I would use Desmos Scientific in this class. Okay, 70 miles per hour, 35 degrees. So the same things that we had before, my resultant velocity vector and my theta. 2 seconds in the air, so that's time. The person hits its target. How far away? How far away? That's the range. It's not how tall. Or how high did the person go? It's how far away was the person from its target initially or at the start. So we need the range there. So what equation do we know right now? Yep, range is velocity in the x times time. So you already have that in the back of your head, but I would recommend also drawing a picture to help you out. Those are our givens. There's our picture. Okay, so we know this is 70 miles per hour and this is 35 degrees. Okay, now it depends. 70 miles per hour, is that going to work? Nope, because our range is not going to be in miles and our time is not in hours. So in this one, you have to convert to meters per second to make sure you're doing conversions on this one. You would not leave that one 70. I am just for time's sake. Okay, so which one? Range. So that means the range is the x direction. Range is the distance in the x. So what are we going to use? We're going to have to use the velocity in the x. They have to match. If you're using the distance in the y, you need the velocity in the y. That's what makes those equations nice and special. Okay. So what do we know? Do we know the range? Nope. Do we know the velocity in the x? We can calculate it, okay? Because we know the velocity in the x is going to be the resultant velocity times the cosine of theta. Just don't use 70 for this one. And what do we use for time? Time is 2 seconds. And that would be our Vx. And there would be our range. Okay, so sometimes you don't need two equations to find your answer. Sometimes it's just in one. Every single time, see what your initial conditions are, draw your picture. 30.2 meters per second is our resultant velocity. So that's the one on the hypotenuse. Our theta is 17.5 degrees, and it rose to a height of 10 meters. So that is our distance in the y, which is 10 meters. Okay, how far does it travel? So again, we want range. This one's kind of similar to the ones that we were doing in the lesson. But if you're like, no, I don't know which equation to start with the range equation. It is okay to start with the range equation and then go, oh, that doesn't give me enough information. What else do I have out there? That is okay for you to help narrow things down. So when we do this, do we have the distance in the x? That's what we're trying to find. So that is our unknown. Do we have the velocity in our x? We do. 30.2 cosine of 17.5. What don't we have? We don't have our time. It did not give us the time. So we're only partially complete here because we need the time to find the range. What do we think about? That projectile time and free fall time are equal. The time something takes to drop directly down or to have that initial velocity and thrown off the edge, the times are going to match or be equivalent. Okay. Now this one's slightly different, right? Because he's hitting the golf ball and it's going up and down. How does that look like? Look, that's only the second half here. Okay. So when I have the time, it's going to be half of the total time. So what do I need to do to find the total time? Multiply times 2. So whatever I find for the free fall, that only gives us half. So I'm going to have to multiply by 2. What equations do I have for the y? Same as the module 1. I'm just going to put up the main one right here, but you could try out the other ones. Velocity initial, in this case, it is a number, 30.2 times the sine of 17.5. We want to find out what the time is. Our total height, we know that, that's 10. Our acceleration, negative 9.8. So in this case, we have 10 equals 30.2 sine of 17.5 plus 1/2 times negative 9.8 times t squared. 30 sine 17.5 times time. So if you notice there, what are you going to have to use? You're going to have to use the quadratic equation for this one, because you're going to end up with a time and a time squared. But you still can find your time, take it times 2, and then plug that equation in there. Okay, so lots of little itty bitty pieces on that one. There was a video with the quadratic equation, or you can go search for the quadratic equation, because again, this thing takes a long time to do. So just know there is a quadratic equation there. It will not take you long to plug it in. Once you look at it, you go, oh yeah, I remember the quadratic equation. That one kind of gets stuck in your brain. All right. The 10-meter diameter carousel. Okay, so have we used diameter at all? No, so probably what we're going to need is 5 meters is the radius. Takes 90 seconds to make 3 turns. 3 turns in 90 seconds. So that's really my frequency. I want to do what? Convert that the other way around. 30 seconds per turn would be our period. So you can think about it doing it that way, or you could use your circumference, either way that you wanted to do it. Okay, what is the acceleration? So we need to figure out what is our equations. Okay. 90 divided by 3, I'm pretty sure is 30. Sometimes I do the calculator wrong. When I'm just doing and talking, but apparently there I did it wrong the other way. Okay. And what's our acceleration formula? It's v squared over r. So we have the radius of 5. Do we have a v squared? That would be meters per second. I do not have a meters per second yet. Could I calculate it? Yeah. 2 pi r over the period, or the circumference over the period, would get that for you. So that's your 5, and that is your 30 seconds right there. So I can then find my velocity, and then just make sure your acceleration is velocity squared divided by r. Are there other ways you could do it? Yep, you could have said 3 times 2 pi r over 90 seconds, because that is still my total distance over my total time for my velocity. Again, lots of different ways to break these guys down. Okay. When we compare free fall to projectile time, what happens on another planet? So on another planet, we can have acceleration due to gravity, but it's not going to be equal to 90 meters per second or 9.80 meters per second square. What do we still know? Okay. If the air resistance is 0, the free fall time is equal to the projectile time. Okay. Time of the free fall is equal to time of the projectile, because there's no air resistance. So as long as we're saying no air resistance, doesn't matter what planet we're on, that is still going to be equatable there. What else do we know? What else do we know? Okay. The path of the projectile is going to be the same. It's going to divert off of the velocity x line, okay, or the distance or the x line, either way you want to say it, okay, because it's going to be pulled down by what? By gravity. Okay. Now the velocity of the x is still going to be constant because there's no air resistance, but as it's going east, it's being pulled down by gravity. So the velocity in the y direction is going to be increasing. So as long as there's not anti-gravity, your velocity in the y direction is going to be increasing. Your velocity in the x is going to be constant. Gravity is still acting towards the center, so it is still pulling it down. Okay. How about, there was a couple things on net forces, which was in the textbook, but then they did not quiz you on it. It's still important to go back and do that textbook. Okay, what equations they gave you? Force equals mass times acceleration. So force in the y is equal to mass in the y times the acceleration in the y. force in the x equals mass in the x times acceleration in the x. What do we know are equivalents? The mass in the y and the mass in the x, those are equivalent because it is the same object that's being dropped or thrown. Acceleration in the y is gravity. Acceleration in the x is nothing. There's no force acting upon it there because there's no air resistance. So the forces in the x would equal 0 because anything times 0 is 0. The force in the y would be a number. Okay, so in the y direction, you will have a net force because you have gravity. In the net x direction, you will not have an x force. That means overall, you are going to have a net force because you're going to have acceleration. As long as you have acceleration somewhere, you are going to have a net force. Okay. If you have a net force, then it is probably not in equilibrium unless there's an equal and opposite force somewhere else. So in this case, gravity is pulling it down. There's nothing pulling it up as an equal and opposite. So it is not in equilibrium. And that's